How are you?
Fine, sir.
Okay. कैसे चल रहा है आप लोगों का पढ़ाई?
चल रहा है सर.
अच्छा चल रहा है, ठीक है. चलो, क्लास में समझ में आ रहा है ऑसिलेशन?
सर.
Okay. Are facing any difficulty?
Sir.
So we have started discussion about forced oscillation and we have finished that forced oscillation, right? अच्छा, ये step given था आप लोगों को. What was given that there are two driving frequency, P equals to 0 and P equals to square root of omega naught square minus twice beta square, right? ये दो driving frequency given था and you have to prove that at this driving frequency the amplitude of oscillation will be minimum. At this driving frequency the oscillation will be maximum. And your function was what? F of p, that was omega naught square minus p square whole square plus 4 beta square p square, right? Okay. So the minima or maxima will be defined by what? Double derivative, right? So let us do the double derivative. So the first derivative of this function will be del f by del p, and that should be equals to minus 4p omega naught square minus p square, right? And you will have 8 beta square p. This will be your first derivative, right? And if you further differentiate this function, it will become del square f by del p square, that should be equals to minus of 4 omega naught square minus p square plus 8 p square plus 8 of beta square. In the second step, what I have done, or third step, first I have differentiated this, then I'll get minus 4 omega naught square minus p square. Then I'll keep this as a constant, I'll differentiate this. So minus 4p you have, if you differentiate this part, you will get minus 2. So 4p minus 2p, that will be your 8p square. And third, this term, the differentiation of this term will be simply 8 beta square, right? So if you further rearrange it, how much you will get? You have 4p square, 8p square, that will be your 12p square. So what I can write? I can write minus of 4 into omega naught square minus 3p square plus 8 beta square, right? I can write, right? Is this part clear to all? Is this part clear?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now, if I substitute p equals to 0, if I substitute p equals to 0, then this term, let us, I can write like f double dash also, right? This term, that will become how much? Simply minus 4 omega naught square minus 2 beta square. Just I have substituted p equals to 0, then I will get minus 4 omega naught square and you have 8 beta square. So if you take minus 4 common, you will get omega naught square minus twice beta square. So this is the case, double derivative case. You have obtained that f double dash equals to this when p equals to 0. And second case, when p equals to square root of omega naught square minus twice beta square, then F double dash will be how much in that case? So here you have to substitute P equals to how much? Omega naught square minus twice beta square. So if you substitute it, you will get minus of 4, then you will have omega naught square minus 3 omega naught square. Just I am substituting that value of P. So you have P square. So just you have to square it and you have to substitute it. So minus 3 omega naught square plus 6 beta square. Then you will have 8 beta square, another term. So that will be how much? If you calculate, that will be how much? I have calculated, you just simplify it. If you simplify, you will get 8 omega naught square minus twice beta square. Is this clear? Is this step? किसी का कोई डाउट है इस स्टेप में?
No, sir.
Is this step is clear, right? Okay. Now what is the difference here? You see, in general, damping parameter is low as compared to your natural frequency under force oscillation. So its order you can note down also. Omega naught basically you can say around 10 beta. Basically omega naught is larger. So if omega naught is larger, this term you already have minus sign. Omega naught is larger, obviously this value will be positive number. This will give you some positive number and you have minus sign. So actually when P is 0, F double dash that will be minus. F double dash that will be minus. It means at P equals to 0, this function will have maximum value. And at P equals to square root of omega naught square minus twice beta square, you will get positive number because this is you have positive number and you have positive number here. So you will get positive number. Double derivative positive means the function will be minimum at P equals to this value. If you remember that your amplitude was inversely proportional to this function. So it means when it is minimum means at this value, you will have maximum amplitude. Okay. Is this clear?
Yes,
किसी
sir.
को कोई कुछ नहीं है किसी को कोई? You have any question?
No, sir.
आप लोगों को सॉफ्ट मटेरियल मिल गया है? स्टडी मटेरियल ऑसिलेशन?
Yes, sir.
ओके ओके. वर्कशीट में काफी प्रॉब्लम्स होंगे. You can practice that problems. So if you have any question of forced oscillation, you can ask me. You have any question? If you don't have any question, then I'll go to that next part, that is superposition of SHMs. Superposition of SHMs. Okay. So first case, addition of. So there will be 3-4 cases. Okay. So first case will be the superposition of two simple harmonic motion having same frequency but different amplitude. So if you add this or if you add these two SHMs, then what will be the outcome? How it will look like? So that first discussion is about addition of two SHMs having same frequency but different amplitude. Okay. So to understand this, let us take two SHM equations. Suppose you have SHM equation phi1, its amplitude is A1 sine of omega t, and let us take that initial phase, that is delta 1. And you have another SHM, its equation is y2 equals to A2 sine of omega 2t plus delta 2. So basically you have two SHMs. Okay. If they superimpose, then what will be the outcome? That we are planning to see. If they superimpose, okay, or if you add them or if you sum them in vector form, then what will be the outcome? That we are going to see. So the net displacement y net will be how much? Now you can see their amplitude for this SHM amplitude is A1, frequency is omega. Okay. For second SHM amplitude is A2, frequency is omega 2. So sorry, this extremely sorry, this will be simply omega. So their frequency will be same, amplitude will be different. So if we add them, then what will be the resultant amplitude and frequency? So let's see. So I net will be simply vector sum of y1 plus y2. So if you add this, or if you write substitute this value of y1 and y2 here, you will get a1 sine of omega t plus delta 1. And for y2, you know that is a2 sine of omega t plus delta 2. Okay. Now I'll use sine a plus b formula. So sine a plus b means sine a cos b plus cos a sine b. So if I write the sine a plus b formula for both cases, and if I take sine omega t common, I will get a1 cos of delta 1 plus a2 cos of delta 2. So a1 cos delta 1, from this term I'll get a1 cos of delta 1, because sine omega t cos delta 1 you have a1. So from here I will get this term, and from here I will get sine omega t cos delta 2 a2. So this term I'll get from this term. So this is all about the coefficient of sine omega t. And similarly you will get cos omega t term. So if you count cos omega t term, so what you will get now? You will get basically a1 sine of delta 1 plus a2 sine of delta 2. Where delta 1 and delta 2, these are basically initial phase of oscillation. Okay. Is this step clear? Nothing I have done, just I use that formula of sine a plus b for both cases, and I have taken sine omega t, coefficient of sine omega t separately and coefficient of cos omega t separately. Okay. Yes. Now let us assume this C, the sine omega t. This is actually, you see, some amplitude and some phase. So I'll assume, for the sake of simplicity, I'll assume this term This term I will assume some variable amplitude A with some phase cos theta. And this term I will assume with some variable amplitude A and phase sin theta. Now your equation will become A sin omega t cos theta plus A cos omega t sin theta, right? You see, now your equation, excuse me, now your net displacement becomes y net, that should be equals to A sin of omega t cosine theta plus second term you have A cos omega t sin theta, cos omega t sin theta. It means if you take A common, you will get sin of omega t plus theta. Okay. So net displacement of two SHMs, they have same frequency but different amplitude, is representing a equation of SHM. You can see ये भी फिर आपका क्या मिला है? This is also the equation of simple harmonic motion. So if two simple harmonic motion, they have same frequency, different amplitude. If they superimpose, the resultant motion will be simple harmonic motion. It will have amplitude that will be A, that we don't know, that we are going to calculate sin omega t plus theta. Theta is some initial phase. So you can represent like this. So what I'm trying to say, again, I'm repeating, resultant will also represent a simple harmonic motion for this case with amplitude A and initial phase theta. Now what will be the A? How will calculate A? Because we know A cos theta was how much? If you remember, A cos theta was A1, anyone? A1 cos of
cos omega 1
Delta.
delta 1 plus A2 cos of
Cos delta 2.
delta 2. And you have A sin theta, that was A1 sin of delta. Let me write this side. So you have A sin theta, that was A1 sin of delta 1 plus A2 sin of delta 2. Now if I square this equation and this equation, and if I sum, what I'll get? I'll get A square equals to, if I sum it, I'll get, if you square and sum it, you will get A1 square cosine square delta 1 plus sine square delta 1 plus A2 square cosine square delta 2 plus sine square delta 2, and also will get term twice A1 A2 cos of delta 1 minus delta 2. You can check there. So it means the resultant amplitude A for this motion will be how much? Simply this will be on cos square delta 1 plus sin square delta 1 on. This will be on. So I can write like square root of A1 square plus A2 square plus 2A1 A2 cos of delta 1 minus delta 2. Right? So this will be your amplitude. So amplitude of the resultant wave is basically depends upon initial phase difference, because delta 1 and delta 2, that you have assumed the initial phase of oscillation of simple harmonic motion, SHM number 1 and SHM number 2. So the amplitude of oscillation will be depends upon the initial phase, because it contains cos delta 1 minus delta 2, right? So the amplitude A will be maximum. A will be maximum, and maximum value will be how much? Maximum value will be how much? Simply A1 plus A2. When it will be possible? When delta 1 minus delta 2, that will be how much? 0, 2 pi, 4 pi, and so on. You can check. If you substitute 0 here, you will get A1 square plus A2 square plus 2A1 A2. That is nothing but A1 plus A2 whole square, and you have square root. So it means it will be A1 plus A2. So for any this value, delta 1 minus delta 2 equals to 0, 2 pi, 4 pi, 6 pi, so on, you will get maximum amplitude, and that will be addition of two amplitude, A1 plus A2. Okay. And the amplitude will be minimum value, and that will be how much? Minimum कब possible है? And that minimum will be A1 minus A2. When it will be possible? When delta 1 minus delta 2, that should be how much? So your amplitude basically depends upon this. तो minimum कब होगा? जब इसका वैल्यू मिनिमम है. इसका वैल्यू मिनिमम कब है? कोसाइन डेल्टा 1 माइनस डेल्टा 2, दैट वैल्यू मिनिमम इज -1. सो -1 कब पॉसिबल है? जब आपका डेल्टा 1 माइनस डेल्टा 2 डेल्टा 2 दैट इज आइदर पाई, 3 पाई, and so on. Okay. So is this part clear what I'm trying to say, everyone?
Yes, sir.
Yes, sir.
Okay. Okay. Now, what will be the theta? So tan theta, if you remember from previous equation, I can write like tan theta will be how much? Tan theta will be simply A1 sine of delta 1 plus A2 sine of delta 2 divided by A1 cos of delta 1 plus A2 cosine of delta 2. So you can represent your theta and amplitude. Theta means initial phase and amplitude from this initial phase and amplitude, right? So this is all about your superposition of two SHM when they have same frequency but different amplitude. So this kind of actually that part is actually we are going for Lissajous figure. So this is the simplest case. After that we will go to Lissajous figure, and that part will be really important and interesting also in my lecture. So is this part clear?
Yes, sir.
Okay.
Yes, sir.
Shall I erase? Have you written this part?
Yes, sir.
Yes, sir.
Okay. If you have understood this part, please solve these two problems. Then we can understand. Suppose you have three sinusoidal waves. You have three sinusoidal waves and its amplitude is given. पहले का amplitude कितना है? Suppose you have three sinusoidal wave, 1, 2, 3. पहला का amplitude A है, दूसरा का A/2 है, तीसरा का कितना है? A/3 है. Okay, they have initial phase is given. Initial phase of this is 0. For this initial phase is pi/2. For SHM number 3, initial phase is pi. ठीक है. अब तीनों साइनोसॉइडल वेव का सुपर इम्पोज हो रहा है. So you have three sinusoidal wave. They have amplitude A/2, A/3, and initial phase is 0, pi/2 pi. So you have to calculate the amplitude of resultant wave. You have to calculate the amplitude of resultant wave. How will calculate? So sinusoidal wave means, let us write for first wave, y1 will be how much? A sine of omega t, because phase is 0, right? Similarly, I can write y2. y2 will be how much? Its phase amplitude is given a by 2 and phase is given pi by 2. So I can write like a by 2 divided by, sorry, a by 2 into sine of omega t, and you have to introduce that phase also. And that phase is how much? Pi by 2. And lastly, for wave number 3, y3 will be how much? This amplitude is given a by 3 and sine of omega t, and you have to introduce that phase, that is pi, right? So y2 I can write like y2 equals to how much? Sine pi by 2 plus theta is how much? Cos theta, right? So I can write a by 2 into cosine of omega 2, sorry, omega t. So y2 further I can write a by 2 sine pi by 2 plus omega t, that is nothing but cos omega t. And similarly I can write y3 sine pi plus omega t, that is nothing but minus sine omega t. So y3 will be simply minus a by 3 sine of omega t. Okay. Now if you add these three, resultant means y net, and y net will be how much? y1 plus y2. So if you add it 3, you see y1 and y3, they have sine omega t. So if you take sine omega t common from y1 and y3, you will get a minus a3, that will be the amplitude. So it will be 2a by 3. So I can write from y1 and y3 2a by 3 sine of omega t. And you have y2, that is a by 2 cosine of omega t. Now can you please tell me what will be the amplitude? What will be the amplitude now? कितना amplitude होगा?
सर इसमें से a कॉमन ले सकते हैं और स्क्वायर कर सकते हैं सर.
Okay, you see, if you remember what I have assumed, the coefficient of sine omega t, I had assumed that was, if you remember, कितना assume किया था मैंने वो? Sum a cos theta, right? Just देखो पिछले वाला discussion. And coefficient of cos omega t को मैंने क्या assume किया था? A sine of theta. That we have assumed, right? If you see that last discussion, coefficient of sine omega t that we have assumed, that was your a cos theta, and coefficient of cos omega t that I have assumed some a sin theta, and a was your resultant amplitude, right? So it means a cos theta equals to 2a by 3. For this case, let us take some different notation, a prime. So a prime cos theta equals to 2a by 3. A prime sin theta, that will be a by 2. So how will calculate? Because a dash or a prime is your resultant amplitude, right? So I can calculate a dash or a prime. Just square both the equation and sum. So if you square and sum, you will basically get 2a by 3 का whole square plus a by 2 का whole square. Just square these two equation and sum them. So a prime square into cos square theta plus sin square theta, that will be 1. So on the left hand side you will have a prime square, and right hand side you will have 2a by 3 chi square plus a by 2 chi square. Now if you take square root, you will get this. Okay. Is it okay? Is this concept clear? So nothing you have to do, just you have to take the coefficient of sin omega t as a prime cos theta. When you will have both frequencies same, but amplitude different. That is the discussion actually. The topic that we are discussing, when both frequencies same but amplitude different. That time you have to take the coefficient of sin omega t as a prime cos theta and coefficient of cos omega t as a prime sin theta, where a prime decides the amplitude of resultant wave. Or a prime is the amplitude of resultant wave. Okay, ठीक है. अब ये वाला प्रॉब्लम बताओ. Suppose you have, again you have three SHM equation, that is Y1 equals to A1 sine of omega t. Okay, Y2 equals to A2 sine of omega t, and Y3 you have, that is A3 sine of omega t plus some phi. So you have three SHM equation. So what will be, if they are superimposed, what will be the amplitude of resultant wave? So suppose you have resultant wave is y net, so what will be its amplitude? कितना हो जाएगा amplitude? बताओ. Anyone? क्लास में समझ में आ रहा है आप लोगों को?
आ रहा है सर.
Then tell
सर
me.
इस क्वेश्चन में एम्पलीट्यूड कुछ नहीं दिया है.
Sorry. Just they have given three SHM. These are the three SHM equation, right? And you have, you see there you have frequency same, amplitude different. So process whatever we have applied, that process you have to apply same. So you have to arrange sin omega t in on term and cos omega t in other term, and then you have to assume that coefficient of sin omega t as a cos theta and coefficient of the cos omega t as a sin theta. Now y net, how will write y net? It will be simply y1 plus y2 plus y3, right? अब y1 का वैल्यू बैठाओ, तो y1 एंड y2 में क्या है, sin ओमेगा t है, ठीक है ना. तो यहाँ पे आपका क्या मिलेगा, a1 plus a2, right? And from y3, sin omega t cos phi a3. So from y3, how much you will get your coefficient of sin omega t? You will get a3 cos phi. A3 cos phi. Okay. And what about the coefficient of cos omega t? So these two terms don't have any cos omega t. This term will have cos omega t coefficient, that will be sin phi a3. So I can write cos omega t or cosine omega t. Then you will have a3 sine of phi, right? The same thing, we assume this as a of cos theta and this as a of sin theta. So what will be the amplitude now? Just square root of a1 plus a2 plus a3 cosine phi, this will be phi, square plus a3 sin phi right स्क्वायर, ठीक है ना। ये किसको समझ में नहीं आया?
सर सेकंड
सर?
स्टेप फिर से बता दो।
ये वाला
सेकंड
नहीं सर,
स्टेप
वो A3 cos phi लिया है ना वो।
ये वाला
नहीं, वो ब्रैकेट के अंदर sin ओमेगा हाँ
यहाँ से
वो
आएगा आपका y3 से। इसको जब आप ब्रेक करोगे क्या मिलेगा? साइन ओमेगा टी कॉस फाई राइट। सो पहले मेरा प्लान क्या है कि साइन ओमेगा टी को एक साथ करना। तो थर्ड टर्म से आपको क्या मिलेगा? पहले दो टर्म से तो a1 a2 मिल गया, थर्ड टर्म से साइन ओमेगा टी कॉस फाई यू हैव a3 राइट। तो यहाँ से जो साइन ओमेगा टी का कोफिशिएंट क्या मिलेगा? कॉस फाई a3 cos phi a3 and you have sin omega t that is contributing by y3 right and cosine omega t only थर्ड टर्म में होगा। वो क्या होगा? जब cos omega t sin phi होगा right। तो cos omega t a3 sin phi। now is it clear?
सर
और कोई क्वेश्चन? फिर इसको कैसे लिखा हूँ समझ में आया? ये वाला
yes sir,
ये वाला समझ में आया सबको?
जी सर।
ओके चलो ठीक। okay so if you have done this part we can move in another case. Shall I erase?
यस सर।
okay okay now second case. So we have discussed only one case, right? Till now, we have discussed one case with two problems, right? Now suppose you have second case, case number 2. Case number 2, addition of two SHMs. Two SHMs having same amplitude. पहले क्या था? Different amplitude, same frequency, right? Now same amplitude, but different frequency. Different frequency. Okay. Addition of two SHMs having same amplitude but different frequency. So I can write like, suppose you have SHM number 1, you have SHM number 2, is equation of SHM is y1 equals to a sine of omega 1 t. So a is the amplitude, omega 1 is its frequency. And for SHM number 2, its equation is y2 equals to a of sine omega 2 t. So I'm taking initial phase that is 0 for this case, and you can see the amplitude is same but their frequency is different. Now if they superimpose the net displacement, I can write y net, that should be equals to how much? y1 plus y2. Okay, and if you substitute that y1 and y2, you will get a into sine of omega 1 t plus sine of omega 2 t. And what is the formula of sine a plus sine b? The formula is 2 sine of So you have sine A plus sine B. So formula is sine of A plus B by 2. So omega 1 plus omega 2 T by 2 cosine of omega 1 minus omega 2 T by 2. Right? Is this formula clear? Everyone?
Yes, sir.
Okay. So further I can write twice A cosine of omega 1 minus omega 2 T by 2 into sine of omega 1 plus omega 2 T by 2. I can write, right? So this is your net displacement. Okay. Is this equation representing simple harmonic motion? So earlier case, if you remember, that time the net displacement of addition of two SHMs was representing simple harmonic motion. But is this case will represent the equation of simple harmonic motion now? सिंपल हार्मोनिक मोशन के लिए क्या कंडीशन क्या है? y double dot should be equals to minus omega square y, right? This is the condition of simple harmonic motion, right? Please respond me. This is the condition, right? Acceleration should be equals to minus omega square into displacement. This is the condition. But earlier case, if you look at that result y net, that you can represent like this: y double dot equals to minus omega square y. But for this case, you can never represent like this. So when two SHMs having same amplitude but different frequency, when they superimpose, the resultant motion will no longer be simple harmonic motion. It will be periodic in periodic motion. It will be periodic motion. But it cannot be simple harmonic motion. It cannot be simple harmonic motion. Now, this term actually what here? Okay, before you see, now interesting part of this result is you have two function here, function of time. One contain cosine function, another contains sine function. Now if we plot them separately, so I'll plot here first cosine function and then I'll plot here sine function. Okay, so cosine function will plot will be like this. So with time, the first cosine function plot will be looking like this. ओके अच्छा, इनमें से किसका फ्रीक्वेंसी ज्यादा होगा? कोसाइन वाले का फ्रीक्वेंसी ज्यादा होगा टाइम के साथ, या इसका फ्रीक्वेंसी ज्यादा होगा साइन वाले का? एनीवन?
साइन वाले का
व्हाई?
ओमेगा 1 प्लस ओमेगा 2.
यस, वेरी गुड. बिकॉज फ्रीक्वेंसी मतलब क्या है? ये नंबर ऑफ आपका नोट्स और एंटी नोट्स, राइट? कितना होगा? तो अगर सेम टाइम में मेजर कर रहे हो फॉर बोथ फंक्शन, यहाँ पे नंबर ऑफ नोट्स और एंटी नोट्स आपको कम मिलेगा, क्योंकि ओमेगा 1 माइनस ओमेगा 2 बाई टी, सॉरी ओमेगा 1 माइनस ओमेगा 2 है यहाँ पे, ठीक है? उसीलिए आपको क्या मिलेगा? इस केस में कोसाइन में आपका फ्रीक्वेंसी कम मिलेगा, बट फॉर दिस केस यू विल हैव मच फ्रीक्वेंसी. सो इफ यू प्लॉट साइन फंक्शन विथ टाइम, it will look like, you can see here you have only two nodes, you will have many nodes there. Okay, what is nodes actually? नोड्स क्या है? नॉन नोड्स, राइट? नोड्स उसी को बोलता है जहां पे आपका पार्टिकल का डिस्प्लेसमेंट जिस पोजीशन पे 0 होता है. We'll discuss this part in standing wave part. Okay, so we'll have many nodes here. That nodes place is this. तो जहां पे पार्टिकल का डिस्प्लेसमेंट 0 होता है जिस पॉइंट पे, उसको बोलते हैं नोड्स. एंड जिस पॉइंट पे आपका पार्टिकल का डिस्प्लेसमेंट मैक्सिमम होता है, लाइक दिस पॉइंट,
Node.
उसको एंटी नोड्स बोलते हैं, राइट? ओके, नाउ यू सी, you have sine function here and you have cosine function here, but net displacement contains both this function, right? If you merge them together, then how it will look like? If you merge them together, it will look like okay. This is the resultant form, right? So how we can infer from this plot that your cosine function actually decide the amplitude of oscillation. You see, cosine function actually deciding the amplitude of oscillation, and sine function actually deciding the frequency of oscillation. So you have two functions there, cosine and sine function. Cosine function actually deciding the amplitude of oscillation, and sine function is deciding the frequency of oscillation. तो देखो यहाँ पे पार्टिकल का जो डिस्प्लेसमेंट एम्पलीट्यूड देखो, एम्पलीट्यूड पहले बहुत कम है, फिर बढ़ गया, एक पॉइंट पे आपका मैक्सिमम आ गया, फिर कम होता जाएगा, 0 हो गया, फिर मैक्सिमम होता गया, सॉरी बढ़ता गया, एक टाइम पे क्या हुआ, एम्पलीट्यूड मैक्सिमम हुआ, फिर कम होता जाएगा, है ना? तो एक ही पार्टिकल का जो ये है आपका मोशन है, उसका एम्पलीट्यूड का वेरिएशन आप देख सकते हो. इनिशियली यू नेवर हैव सीन, but when two simple harmonic motion, they have different frequency, same amplitude. When they will superimpose, they will have, they do not have any simple harmonic motion, they will have periodic kind of motion, and they will have amplitude. कभी आपका बढ़ता जाएगा, फिर इंक्रीज हो जाएगा, फिर घटता जाएगा, 0 आ जाएगा, फिर बढ़ता जाएगा, ऐसे फॉलो अप होगा. ठीक है? So your y net, that what we have discussed, y net was how much? 2a cosine of omega 1 minus omega 2 t by 2 into sine of omega 1 plus omega 2 by 2 into t. So this term actually representing the amplitude. So this term representing the amplitude of oscillation, that is function of time into sine of omega 1 plus omega 2 t by 2. लास्ट वाला प्लॉट समझ में आप लोगों को? ये वाला क्या हो रहा है?
Yes, sir. आगे.
किसको नहीं आया? प्लीज टेल मी ऑनेस्टली. कोई क्वेश्चन है इसमें? Anyone has any question here? Okay. If you do not have any question, we can move further. Okay. Now amplitude is a function of actually time. So a of t actually this, right? And we know the intensity of any wave, how it is related to amplitude. intensity of any wave related to amplitude, that is intensity I is nothing but proportional to a square, right? I is proportional to a square. This thing you know, right? आप लोगों को ये पता
Yes,
है
sir.
ना? The
Yes, sir.
intensity of wave is proportional to amplitude square. Okay. Now amplitude is this. So I can write that intensity for this case will be proportional to cosine square of omega 1 minus omega 2 t by 2. तो मैक्सिमम इंटेंसिटी कब होगा फिर? ठीक है, तो आपको आपका होमवर्क ये है कि मैक्सिमम इंटेंसिटी किस किस टाइम पे मिलेगा आपको कैलकुलेट करनी है. ओके, और मिनिमम इंटेंसिटी आई मीन मिनिमम इंटेंसिटी किस किस टाइम को मिलेगा वो आपको कैलकुलेट करनी है. दिस इज योर होमवर्क. ओके, so you have to calculate when we will get maximum intensity at what time. So t will be a function of, I'm writing t will be a function of frequency, some frequency f1 f2 like this. Okay, so you have to calculate f1 and f2 are frequency. You can convert from omega to f, right? So at what time you will get the maximum intensity and when you will get minimum intensity. So you have to calculate from this equation. This is your homework. Okay, can you able to solve?
Right, sir.
Yes, it's a very simple. कब मैक्सिमम होगा? जब cos का वैल्यू प्लस माइनस 1 हो, क्योंकि cos स्क्वायर है ना यहाँ पे. तो अगर cos ओमेगा 1 माइनस ओमेगा 2 into t divided by 2, when it will be plus minus 1, then you will get maximum value I. Maximum value of I you will get when cosine of omega 1 minus omega 2 t divided by 2, that should be equals to plus minus 1. प्लस माइनस कब मिलेगा आपको? when 0
0, pi, 2 pi, 4 pi.
that corresponding time you will get, and that will be the reciprocal of f1 and f2 like this. You calculate it, it's very simple. And similarly you will get, when you will get minima, minimum value will be how much? cos square का minimum कितना होता है? 0 होता है.
Pi, 3 pi.
नहीं, cos square है ना यहाँ पे. cos square का minimum value कितना होता है? cos square का minimum value अब -1 नहीं है.
0, 2 pi.
2 pi क्यों?
0.
0 नहीं, आप लोग समझ नहीं
Cos
रहे.
pi, cos pi by 2.
हाँ, I will be maximum when I will be maximum. I will be maximum when cos square, this value will be how much? +1, right? This value will be +1. Cos square omega 1 minus omega 2 divided by this will be +1. It means what I'm trying to see, I proportional to cos square, right? So I will be maximum when cos square will be maximum. Now maximum cos square कितना होता है? +1 होता है. तो cos square of omega 1 minus omega 2 t by 2, that कितना हो सकता है? कितना है? मैक्सिमम 1 है. इसका मतलब क्या है? cos omega 1 minus omega 2 t divided by 2, that can be plus minus 1. ठीक है, प्लस माइनस 1 कब मिलता है? 0, पाई, 2 पाई, so on, है ना? तो इसका कॉरेस्पॉन्डिंग आप टाइम निकाल लो, है ना? 0 प्लस माइनस मतलब क्या लिखोगे इधर? प्लस माइनस 1 के लिए क्या लिखोगे आप? कॉस ऑफ किस किस में मिलेगा आपको? 0, पाई, 3 पाई, सॉरी पाई, 2 पाई, 3 पाई, सो ऑन. तो इसका कॉरेस्पॉन्डिंग आपको टाइम मिल जाएगा. समझ में आया? अब नहीं, अभी भी नहीं आया होगा.
आ गया सर.
सबको आ गया? किसका क्वेश्चन है? अभी भी प्रॉब्लम है?
सर इसका करस्पॉन्डिंग हमें टाइम निकालना है।
हाँ, मैक्सिमम के करस्पॉन्डिंग टाइम कैसे निकालोगे वो मैं जस्ट हिंट्स दे रहा हूँ, कैलकुलेट आप लोगों को ही करनी है, ठीक है। अभी टाइम नहीं निकाला, ये स्टेप समझ में आया आप लोगों को, यहाँ से कैसे इसको लिखा हो।
यस सर।
हाँ,
अच्छा
मतलब मैक्सिमम कब मिलेगा, इस वैल्यू के लिए मिलेगा, 0 पाई 2 पाई 3 पाई के लिए। अब मिनिमम के लिए कितना, मिनिमम कितना होता है कॉस स्क्वायर का वैल्यू, 0 होता है, राइट। तो 0 कब मिलेगा आपको, पाई/2, 3 पाई/2, 5 पाई/2, है ना, है ना। तो इन जनरल अगर देखोगे इसको आपको मिनिमम के लिए 2n + 1 पाई/2 से इक्वेट करना पड़ेगा, और मैक्सिमम के लिए क्या करना पड़ेगा, n पाई से इक्वेट करना पड़ेगा, है ना। थोड़ा कोशिश करो, हो जाएगा, ठीक है। इतना टाइम में तो मैं कर ही देता आप लोगों को। चलो, ऑलरेडी टाइम हो चुका है, वी शुड स्टॉप हियर। ओके,
थैंक यू सर।
ओके,
थैंक यू सर।
वेलकम।
Bye.